Sometimes humans have a different number than 46 chromosomes. This can happen if there is a problem during meiosis. Only during meiosis, not necessarily mitosis. A non-disjunction is when chromosomes don't separate properly. Let's break the word down. A junction is when things come together. A disjunction is going to be when things come apart. So a non-disjunction is when things don't come apart. It's a little bit of a double negative. However, in meiosis, the chromosomes are supposed to separate. They're supposed to have a disjunction. If that doesn't happen, then that can result in chromosomes, or in cells that have the wrong number of chromosomes. So a disjunction can happen in meiosis 1 or in meiosis 2. In meiosis 1 on the left, you can see these two chromosomes don't separate. So the cell that forms on the right isn't going to have this chromosome. And the cells that form on the left are going to have two copies of it. In meiosis 2, we can also see a non-disjunction. So over here, this one separates like it's supposed to. But in anaphase, this one doesn't separate. So this cell is going to end up with two copies of this chromosome. And this cell is going to end up with no copies of that chromosome. So if you look at the bottom, you can see the gametes that result from these two cells. And when the non-disjunction happens in meiosis 1, all of the gametes have the wrong number of chromosomes. The ones on the left have 3, and these have 1, when they were supposed to all have 2. When it happens in meiosis 2, only 2 of the chromosomes have the wrong number. So we still have the possibility here of getting a normal chromosome as the gametes, but there is a possibility of having one too many or one too few. A karyotype is just an organized display of homologous chromosomes. So these are collected from cells. We usually do this with fetal testing. So during an amniocentesis, we would collect cells from the fetus. These are then put into a lab, and they're stained and then organized by size. So you can see on here we have chromosomes 1, 2, 3, 4, 5, and so on, all the way to 22. And then the last two chromosomes are the sex chromosome. So this individual would be a male because they have an X and a Y. These are typically collected from the cells during metaphase. And you can see the structure of the cells. These are duplicated. They have the centromere, sister chromatids. And then this is a set of homologous chromosomes. So this would be a normal karyotype. This individual has 46 chromosomes. 2 of them are sex chromosomes. Sometimes when we have the wrong number of chromosomes, they can result in genetic disorders. One example is trisomy 21. So you can see the karyotype for this girl, and she has 2X, right? So she's female, and she has 3 copies of chromosome 21. This is why it's called trisomy 21. Tri means 3, and soma means body, so each chromosome would be a body. Down syndrome is really common. It's the most common genetic disorder in humans. About 1 out of 800 births is Down syndrome. But if you look on the graph on the left, the incidence, so the number of infants born with Down syndrome, increases as the age of the mother increases. And this risk factor really starts to go up around age 35. And then it increases exponentially. We think that this has got something to do with the mitotic spindle during anaphase, that as the woman is older, that the spindle fails more often. But we're not 100% sure what causes Down syndrome in older mothers. We also tend to see non-disjunctions of the sex chromosomes that can result in people with an extra X or an extra Y or a missing X. So 2 that are common are called XXY, which is Klinefelter syndrome, This person would normally present physically as male because of a Y chromosome. They would be sterile, have underdeveloped testes, and sometimes have secondary female sex characteristics like curvy hips or breasts. XYY is sometimes called supermale syndrome. This is usually normal. There's not really any symptoms. Sometimes these people appear a little aggressive or tall. XXX is called triplo X syndrome. There are usually no symptoms of this. Sometimes these women are slightly taller, but usually there's no physical symptoms. And then XO, the O stands for a missing chromosome. So this would be somebody with an X that doesn't have a second chromosome. And this is called Turner syndrome, and they would present as female because they don't have any Ys. This one is usually sterile, and they have immature sex organs. They tend to be very short and have kind of a webbed, thick neck. So the most common ones we see in humans are trisomy 21, Down syndrome, and then these abnormal sex non-disjunctions. We don't tend to see chromosome 1 trisomy or chromosome 5. Most offspring that have an abnormal chromosomes on numbers 1 through 20 tend to become miscarried or aborted because they're not a viable fetus.